All right, Mr. Trutner here. We're going to go over rules of exponents. And this is going to be a review. So a lot of the information that I'm going to be talking about right now will be information that you already covered. Actually, all of the Math 2 classes covered this information way back in January when we came back from Christmas break. Okay, so a couple things, first of all, about rules of exponents, and I just want to go over some terminology because you're going to hear me saying these terms. I don't know how to spell, sorry, it's early in the morning. So terminology, there we go. I'm going to be saying a lot of these terms as I talk, so I just want to make sure you guys understand what we have. So let's say that I have x and then I have to the power of 5, okay? All right, so terminology that you're going to hear is, and this is information that all of you already know, but it's good to review it. So where the 5 is, that is what is called the exponent. And the exponent is always raised up higher than this here, and it's usually written in a little bit of a smaller font, okay? And then whatever is below the exponent is what we call the base. So in this case, we would say that this problem has, or this expression has, a base of x and an exponent of 5, okay? And then if you ever see something where we have a base, and the base could be anything, by the way. So if the base does not have to be a variable, a letter. So if we could have a base of a number like 9, and then we could have an exponent of whatever we want, okay? And we'll get into, like today, what happens if exponents are negatives or something like that. But let's just keep it simple right now. Say 3. In this case, our base would be 9. Okay, so 9 would be considered the base, and then 3 would be called the exponent. All right, so just that terminology that we have there. All right, so then what happens though if we have a base that is a variable, like say y, and then we have a number in front of that variable, say like a 5, and then we have an exponent that it could be anything. Let's make it a 7 here. All right, so we know that 7 would be called the exponent. We know that y would be called the base. Anything immediately below the exponent is called the base. And the new terminology that we haven't talked about yet in this video, but you know, the 5, so the number in front of the variable is what we call the coefficient. Okay, so that 5 would be called the coefficient. And you need to know this because as I go over the rules of exponents, you're going to be hearing me say base a lot, you're going to be hearing me say exponent a lot, you're going to be hearing me say coefficient a lot. Okay, and there's going to be, let's see, how many rules? We're going to go over 5 rules of exponents that we need to review today. And these will coincide with the video or the worksheet that you're going to be doing for one of the worksheets you're going to be doing for the week. Okay, so the first rule of exponents is going to be what we call the product rule. Okay, so the product rule of exponents. All right, so what does the word product mean? The word product means that there's going to be multiplication involved. So whenever you see the word product, you're immediately in your brain, you need to click off that, oh, this means that it is a multiplication type problem, okay? And what we're going to do is we're just going to do 3 examples of each. We'll do kind of a very basic level, and then we'll do a medium and then a more difficult one. But this is what the product rule says. The product rule says that if you are multiplying, notice there's the word product, okay? Product means multiply. If you are multiplying 2 expressions that have the same base, Notice both of these, I am multiplying, both of these expressions have a base of a. The product rule of exponents says to simplify this expression, you basically merge the two bases together and you make it one base. So if the bases are both a, then you merge it as just one base of a, and then you add the exponents up. So a to the power of n times a to the power of m. When we simplify that, it becomes a to the power of n plus m. So notice we don't multiply the exponent values together, we add the exponent values together. And this rule only works if you have the same base and you're multiplying, okay? So, example number one, a very basic example. So let's say I say simplify x to the third, and in each one of these problems what we're going to be doing is we are going to be simplifying each expression that I give you, okay? So let's say I have x to the third and I say what does it simplify to if I multiply it by times x to the 8th power? All right, well, notice, according to the product rule of exponents, what we do is if these both of the expressions have the same base, and they do, what's the base? It is x. You merge the base together, and then to simplify, you add the exponents up, okay? So x to the third times x to the 8th would simplify to x to the 11th power. All right, do not multiply the exponents together. All right, so that would be your first most basic example. Your second example would be, all right, so Mr. Tretna, I understand that. I understand that when we're multiplying, we add the exponents up as long as the two expressions have the same base. But what happens if the expressions have coefficients in them? Okay, that would be the second example. So let's say I say take 3y to the 6th power, and then multiply it by 5y to the 2nd power. Okay, so what you do here is if you have coefficients involved, to simplify this expression, you actually multiply the coefficients together. So you would go 3 times 5, and then for the expression that has the exponents, which is y, notice both of these exponents, 6 and 2, have a base of y. You merge the two y's together as one y, and then the rule says when you're multiplying, you add the exponent numbers up. Okay, so 3y to the 6th power multiplied by 5y to the 2nd power would simplify to 15y to the 8th power. All right. Okay, example number 3. So now example number 3 would be what happens when we have multiple variables involved in our expression. So in other words, what happens if we have a to the 4th, b to the 6th, c to the 8th, multiplied by a to the 2nd, multiplied by a to the 5th, b, c to the 7th. Okay? So in this problem, you can see I'm multiplying 3 expressions together. Some of them have bases of a, b, and c. This middle expression only has a base of a, and then this last expression only has bases of a and b and c. Okay, now the first thing is, if you notice right here in the third expression, the a to the 5th b, this b has an exponent, okay? So if you don't see an exponent, what is the exponent? It is always a 1. All right, you're never going to see anybody write the 1, but you have to know that. Okay, so how do we simplify this expression right here? All right, well, we're just going to use the product rule. But we can only use the product rule for expressions that have the same base. So let's start with the a's. So notice I have an a to the 4th power, and then I'm just going to move along and see if there's another a. So I'm going to add that 2 to the 4. I'm using the product rule. And there's another a, so I'm going to add that 5 to the 2 and the 4. So when I combine all the a's together using the product rule, I'm going to get a to the 4 plus 2 plus 5. And I'm going to continue that for the b's. So I have a b, and I have a 6 power. I'm just going to follow along the problem, and then I have a 1 power, so I'm going to add 6 and 1 to simplify the b's. And to simplify the c's, I have a c to the 8th power. And then I'm going to follow this along, and notice I have a 7th power here. So when I simplify this entire expression, I would get a to the 11th power, 4 plus 2 plus 5 is 11, b to the 7th power, 6 plus 1 is 7, and c to the 15th power. Okay, so that right there would be your first rule, which we call the product rule of exponents. All right, so then the next rule that we're going to go over would be well, the opposite of the product rule, which is the opposite of multiplication, which is division, and we call that rule the quotient rule of exponents. Okay, so the next rule is what we call the quotient rule of exponents. All right, so what is the quotient rule of exponents? Now, first of all, before I tell you what the rule is, just remember, quotient is a very fancy mathematical word for saying that there is going to be division involved in this problem. Okay, so you're going to see a division symbol, or more likely, you're not going to see a division symbol, you're going to see a fraction, which means division. Okay, so here's what the quotient rule says. It says that if you have a base with an exponent, so once again, our base is a, our exponent is n, and if you are dividing that by another exponent that has the same base, well, notice both of these exponents have a base of a, it says, the quotient rule says, to simplify this problem, you merge the two bases together as one base, a, and then you subtract the exponents, and it's always the denominator exponent, the m, subtracted from the numerator exponent. Okay, some students always say, oh, it's always the top exponent minus the bottom exponent, or the numerator exponent minus the denominator exponent. But that would be the rule right there. Okay, and so once again, what we're going to do, we're going to go over 3 examples to show you how this rule works, and we're going to be simplifying each one of the examples. Okay, so number 1, here we go. So this is like the most basic of examples using the quotient rule. So the first example would be, let's say I have z to the 12th power, and then I'm dividing it by z to the 3rd power. Now your natural inclination would be, oh, I just want to divide the 12 and the 3 together and say that this is z to the 4th power. No, no, no. That's not what the quotient rule of exponents says. The quotient rule of exponents says that to simplify this, you're going to combine the bases as one base. That would be, you combine the z's as one z, and then you subtract the exponents. And then it's always the numerator exponent minus the denominator exponent. So z to the 12th divided by z to the 3rd, when you simplify it, it becomes z to the 9th power. Okay? So you're subtracting the exponents when you see division involved. All right, example number 2 would be, what happens if we have a coefficient with a base and with an exponent? So 20y to the 9th divided by 4, I'm sorry, I said y, but it's actually w. I actually know my letters. Okay, Mr. Kendall taught them to me there. And w to the 2nd power. Okay, so how would we simplify this problem? So when you have coefficients involved, the rule is you actually divide out the coefficients. So you would just divide the 20 and the 4. So you would go 20 divided by 4, and then you would take the bases, which is w, merge them together as one base, and then you subtract the 2 exponents, 9 minus 2. Remember, it's always the numerator exponent minus the denominator exponent. So this particular expression would simplify to 20 divided by 4 is 5, w, 9 minus 2 is 7. So it would simplify to 5w to the 7th power. All right? So then the last example would be, what happens if we have multiple variables involved in a problem. And let's throw in some coefficients here too. Okay, so what happens if, let's say, I had 9 r to the 5th, s to the 8th, t to the 12th, divided by 12 r s to the 8th power, this is a good one here, t, and let's throw in a negative exponent of, say, -4. And don't freak out about the negative exponents, we'll get to that in a second. Okay, all right, so what do we do here to simplify this expression? Well, so remember, the first thing that we do is we divide the coefficients up, but there's a problem here. 9 divided by 12 does not divide out evenly. So the rule is that if the expression does not divide out evenly, 9 over 12, what you want to do is you want to reduce it. Okay, so we're going to reduce each one of these coefficients by dividing by 3. So 9 over 12 would reduce to 3/4. Okay, and then for the rest of the problem, I'm going to use the quotient rule. So for the r's, I'm going to take the r's that have the same base, merge them together, and then I'm going to subtract the exponents. Now remember, this r has an exponent of 1. So I'm going to have r to the power of 5 minus 1. And notice where I put the r, I put it in the numerator. Okay, so if you end up with something on the denominator, in this case a 4, when you follow the quotient rule, put the variables in the numerator. Okay, so then I'm going to combine the two s's together. So I'm going to have s, and I'm going to go 8 minus 8. All right, and then I'm going to combine the t's, and to simplify the t's, I'm going to have a t, and then I'm going to have a 12, and you've got to be careful here because it's 12 minus a -4. Okay, so what does this work out to? Well, this works out to, I'm going to have a 4 on the denominator, and on the numerator, I'm going to have an r, or 3, I mean, r to the 4th power, s to the 0 power, 8 minus 8 is 0, t to the 16 power, 12 minus -4 really means I'm going 12 plus 4, so that's 16. Okay, and then actually you can simplify this even further, because you guys need to remember that anytime you see anything to the 0 power, anything to the 0 power turns that entire base and exponent just into the number 1. So this means I'm left with 3 times 1, which is 3, r to the 4th, t to the 16 over 4. That's what that problem would simplify to. Okay? All right, 2 more rules to go. The next rule is what we call the power to a power rule. All right, so rule number 3, I guess, would be the power to a power rule. To a power rule. Okay, so this rule says, so when I have a power to a power rule, what this looks like is, or what this rule says is, this means you're going to have a base, let's call the base a, with an exponent of n, and it's typically going to be inside a parentheses, and then outside the parentheses will be another exponent. Okay, so what we have here is we have an inside exponent of n with a base of a, and we have an outside exponent of m. And so what the power to a power rule says, to simplify this expression, you would leave the base as whatever it is, which is a, and then you multiply the inside exponent multiplied by the outside exponent. So a to the power of n, then to the power of m would simplify to a to the n times m power. Okay, and so what we're going to do is, once again, I'm going to give you 3 examples, and we're going to simplify each example, and then we'll move on to the final rule. Okay, so example number 1, the most basic of ones. So let's say let's apply this power to a power rule. Let's say I have x to the 6th power in parentheses, and then outside the parentheses I have a 3rd power. So notice I have a base of x, I have an inside exponent of 6, I have an outside exponent of 3, so when we say a power to a power rule, it would be 6 and then the power of 3. So the rule is to simplify this expression, you leave the base, x, and then you multiply the inside exponent multiplied by the outside exponent, so this would simplify to x to the 18th power. Okay? Example number 2 would be, what happens if you have an inside with a coefficient? So let's say I have 2y to the 5th power, then the outside exponent is to the 3rd power. Okay? Well, this one right here is the biggest mistake that you could make in this problem, which is a very typical mistake, is that many students would simply just do this. And this is wrong, so I'll put a big circle with the slash through it. So what a lot of students would do is they would take the 2, and then they would go, oh, I know what to do. I take the inside exponent 5, and I multiply it by the outside exponent 3. Therefore, this problem would simplify to 2y to the 15th power. Okay, so now once again, do not do that. That is a very common mistake. All right, and so here's the mistake. So you should be asking yourself, well, gee whiz, if that's the mistake, what was the mistake? Okay, so here's what I need to ask you guys here. And if we had a class, you would like vehemently answer this. But if I said that power of 3, do you think it's just for the y in the 5th power, or do you think it's for the 2 and the y to the 5th power? And you guys would enthusiastically say, yo, Mr. Tretna, that 3 is for the 2 and it's also for the y to the 5th. And the reason for that is because this whole part is inside the parentheses, so that 2y to the 5th is the base for the 3rd power, okay? So how would we simplify this? Well, here's how. We would have to take this 3, and we would have to apply it to the 2, so that would make that 2 to the 3rd power, and then we would also have to apply it to the 5, and of course that's where we would use the power to a power rule, and we would multiply the inside power times the outside power. Okay, so and then technically, if you're wondering where this 3 came from, remember technically this 2 has an exponent, you can't really see it, it has an exponent of 1. So you would go 1 times 3. That's where the 3 came from. I guess I could write that. So that's where we got that 3 from. Okay, so what would this become? Well, this would become 2 to the 3rd power, y to the 15th power. And then remember, what does 2 to the 3rd power mean? Well, that means 2 times 2 times 2. So really, this problem would simplify to 8y to the 15th power. Okay, so that would be an example of what do you do when you have an exponent on the inside. All right, hopefully that makes sense right there on how to work that one out. All right, so I don't think we need to do a 3rd example of that one, because most of the examples that you're going to see will involve either just basic ones or ones that have a coefficient. And this brings us to our last example, or our last rule that we're going to have. And then the last rule is what is called the negative exponent rule. Okay, so you need to know, what do you do when you end up with answer, a simplified expression that is going to have negative exponents in it, negative exponent rule. So let me tell you what the rule is first, and then let me kind of give you the idea of how to do it. So the negative exponent rule says that, let's say we have an exponent with a base of a, and let's say that, but the exponent is negative. So notice this exponent is a negative n, and this base is an a. So the negative exponent rule says that this would become 1 over a to the positive n exponent. All right, so what I tell my students is, I say, listen, when you have a negative exponent, think of the base as a fraction if it's not a fraction. So you think of this a as like being a over 1. And basically what you do is you flip the fraction around. So notice the 1 became the numerator where it was the denominator, and then the a, which was on the numerator, ended up on the denominator, but when you flip it, the negative exponent becomes a positive exponent, okay? So that would be one aspect of the rule, and the other aspect of the rule would be what happens if the negative exponent is in the denominator. So let's say you had 1 over a to the negative n. Well, this would simplify to, we would flip it, and this would simplify to a to the positive n. Now you might be asking, where did the 1 go? Well, remember, the 1, because it was on the numerator, when we flipped it, it would end up on the denominator, and you don't have to write the 1 there, because that would just, it's inconsequential. So that would be a to the n power. So the thing to remember is that when you have negative exponents, okay, you cannot, and I'll underline that 3 times because this is big, you cannot have negative exponents in any answer. Okay, so I'll put that in like brackets there. All right, so number 1, let's do a couple examples of this so we get the idea of negative exponents. So let's say that, and what we're going to do in these examples is we're going to kind of combine the rules that we just learned from the power to a power rule, the product rule, and the quotient rule. So let's say I tell you to, and once again, we're going to be simplifying these expressions, okay? So let's say I say x, simplify x to the 3rd power multiplied by x to the negative 8th power. Okay, so how do we simplify this problem? Well, this is a multiplication problem, so we're going to use the product rule, which says to simplify this, we're going to merge the 2 bases together, so we're going to have a base of x, and then we're going to add the exponents up. So we're going to take the exponent of 3, we're going to add it to the exponent of negative 8, and this would be equal to x to the negative 5th power. Okay, well, once again, right here, you cannot have negative exponents in any answer. Notice my answer is x to the negative 5th power, so now I have to apply the negative exponent rule. All right, so remember, think of this base, this x, as a fraction, the base up with a denominator 1, and then to actually write this answer, we're going to flip the fraction around. That's called, we're taking the reciprocal. So the 1 would end up on the numerator, the x would end up on the denominator, and then the negative 5 stays attached to the x, but it becomes a positive 5 when you do the reciprocal. So that would be my final simplified expression. X to the 3rd times x to the negative 8th would simplify to 1 over x to the 5th power. Okay. Another example that you may or may not see would be what happens if you have, let's say, y to the 3rd power divided by y to the 7th power. It's all in parentheses, and then outside the parentheses is a negative 2 power. So in this problem, we have 2 rules going on. We have division going on, so we're going to have to use the quotient rule of exponents, and then we have powers to a power. Okay, so when we do this, follow the order of operations. Okay, so how would we, if I said operate this problem, what's the first operation you would have to do? You would simplify out the inside of the parentheses. So what would you do with the 3 and the 7? Well, that's the quotient rule. That's where you subtract. Okay, so to simplify this out, my parentheses, my inside of my parentheses, I would merge the 2 y's together into 1 y. And then I would subtract the numerator exponent 3 minus the denominator exponent 7. And then I would still have this negative 2 power on the outside. So this problem then would simplify to, I would have inside the parentheses y to the negative 4 power. And then outside I would have a negative 2. Okay? And then what I would do now is then I would use the power to a power rule, all right, which says if I have an inside exponent and an outside exponent, I multiply those two together. So this problem would become keep the base of y, and you would go -4 times -2, so that would be equal to y to the 8th power. Okay, hopefully that all makes sense. There'll be a video or an assignment attached to that.